just a little more on IP addressing, because right now we're in transition between IP version 4 and IP version 6. Now, what does that mean? What does that really mean to me? You'll see there, again, an example of an IP address you see there is an IP version 4 IP address. It's 32 bits long, 32 ones and zeros. And if you line up those 32 ones and zeros, that gives us 4.3 billion unique IP addresses. You may think, well, wow, that's a lot, right? That's a lot of IP addresses. And so that is a lot. But go back now and think about Internet of Things. Think about every cardboard box got an IP address, perhaps, or every cow in a field. I know that's an exaggeration. But we now have a lot of things on the Internet, on the big network. And as a result of that, we ran out of IP version 4 addresses. We ran completely out. And so the people in charge of such things sat down and says, hey, we need a new IP address scheme. And they came up with IP version 6, IPv6. IP version 6 is 128 bits long, which gives us a number like 3.4 with 37 digits out there. It's unpronounceable, that number. It gives us a lot of IP addresses. I'm told it's like 4.5 million IP addresses for every human on the planet. And so that's a lot of IP addresses, and maybe that'll cover us for a while. And so IP version 6 is where we're headed to. So we got IP version 4, there's 5. What happened to 5? Well, there was an IP version 5. It's an experimental version. It was for voice and video streams. Never was really adopted. But it claimed the number 5, and so they jumped from 4 to 6. And so that's where we are today. So we're now transitioning from 4 to 6. That means now that every router, for instance, we know now that routers help to manage IP addresses. But if a router is only aware and only has enough space to manage a 32-bit IP address, then that router has to be updated with a new router that's going to accommodate 128 bits. And so there's a lot of transition right now because of this transition from the old IP version to the new IP version 6. What should I know? I should right now have an OSI overview in my pocket. And I should begin to know things like layers 1, 2, and 3. They're the ones that are most important to me. I should understand that the IP address is kind of like a logical address, right? It's a temporary address for a particular end device. And it's managed at layer 3. It's assigned by the network administrator. And routers use IP addresses. That's what we should know about the IP address. If you can think about the example of the postal code. At this point, we should understand some things about the MAC address as well. It's more the physical address, and it's managed at layer 2. It's assigned by the hardware manufacturer. It's burned in, it's solid, it stays there forever. It's absolutely unique to all others. And we should know that switches, network switches, use MAC addresses to move packets around. We should also maybe know at this point that the wireless Ethernet networking, which we call Wi-Fi, it's a layer 1 and layer 2 technology. How about that? It's one of those technologies that kind of sits, one of those areas that sits across a couple of different layers of the OSI model. We should know some things about IP addressing, simply that IP version 4 is going away, IP version 6 is coming in, and that right now in 2014 we are heavily in that transition. It'll be going on for a long time. And we know that all devices, every device out there, has to transition from this IP version 4 to IP version 6 eventually.